So I do not have a slide that talks about me. Okay, this works. So I'm AB. That's it. Nothing serious. Today, I want to talk to us about exploring railway-oriented programming in Ruby, Monads. So I'll start asking, how many of us here are familiar with the term railway-oriented programming? Okay, so I have a lot to do. I was hoping to just say, I was hoping everyone would just say me and I'll be like, yeah, let's go, bye. But nah. So, how do we start? Seeing that a lot of us have to do this together. And spoiler, we're going to code together, live coding. I know it's not the obvious choice, so if anything goes wrong, it's you, because we're doing it together, so I'll blame you, not me. Before we can, just the way we have OOP, DOP, we also have ROP, Railway-Oriented Programming. So in the course of this talk, when I say ROP, I mean Railway-Oriented Programming. I'm sure you're tired already of hearing Railway-Oriented Programming. So I'll just say ROP. Before we can effectively talk about ROP, we need to discuss this guy. How many people know this guy? One person. Okay, so this is Scott. His name is Scott Walshin. He's the author of the book, Domain Modeling Made Functional. Amazing book. But, interestingly, he's also the inventor of the term ROP. Yeah, I'm not going to say railway-oriented programming. I just said it. So what is ROP? Let's get into details. According to Scott, ROP is a functional approach to error handling. Scott is a proponent of functional programming, so I'm not surprised that he did find a way to talk about error handling in a functional way. But what has error handling got to do with railways? What do programmers have to do with railways? Let's see. This is a typical railway. So let's say we have a train that's here. Can everybody see track A here? It's conversational, so I'll expect responses. Okay, so this is track A here. Let's say you have a train right there, and the train needs to get over there, track B. How's it going to get there? Imagine that, yeah, we just had one track, and you could only go on track A, but now you want to move to track B. How is it going to get there? It's going to get there via that thing. I don't want you to feel left out, so I'll come here too. This thing here called a railway switch, this is how the train is going to get from track A to track B, because usually it will go straight down. But now it's like, nah, something happened, need to change, and then via the switch, it goes to track B. What has any of this got to do with us? So Scott found a way to utilize that same analogy to error handling. And now we have two tracks, a success track and a failure track. In essence, a process comprises of several functions, right? So let's say you have a full process. It's a combination of several little different other tiny processes. Now, Scott found a way to say, just the way we have switches in the railway, the outputs of each of these little functions that make a process would be the switch. And then the train would be the process. Are we following? So the process is the train, and then the switch is the what? Output of all of the different little functions that make up that process. Practical example. This is Scott's example, and as was it Alessandro that said, we do not need to reinvent the wheel, right? This is his example, so I'm just using it exactly as he used it. I found it very easy to understand. So let's say we have an entire process to update a user's details. The three tiny little functions that make up this process are validate user, update their details, and send success email. In ROP, this would look something like this. So each of them have their tracks, and if the validate function fails, the process moves where? Where does it move? if validate function fails, remember that the train is the process, right? And the switch is the result of each of the little functions that make up that process. Are we following? So, if the result of validate function is a failure, what happens? Does the train stay here or does it move here? Red track. Thank you very much. Red track. That's because validate failed. But if it didn't fail and it was successful, what happens? Perfecto. So it moves over to the next. And if that fails, what happens? Thank you. So you get the point. The entire process is either a success or a failure based on the outputs of each of the functions that encompass it. Is that clear? Does everybody understand that? So basically, it's like saying this process starts on the success track, and once there's any failure result, it's like, oops, not going there anymore. You can't keep up. With code, this will look something like this. Ignore anything that you see that looks not normal, not like something you would write, like the return email not sent. It's pseudocode. So basically, oops, that went so fast. Basically, what we have here is we try to validate the user. If there are errors, we return the errors, right? But if there are no errors, we move on to update details. If there are errors, we return the errors. And if not, we keep moving. At the end, we can say it's successful because all of the little functions that made up that process were all successful. Does that make sense? Okay, so, but what did we have? If this, return this. Else this, return this. Unless this, do this. Right? But what do we want? Thank you. We want something that's readable. We want something that you can look at and love. You know, okay, so he was saying something yesterday about a director who saw some code and was like, this code is shitty. But we don't want that. You want to be able to see code and be like, who wrote this code? It's so beautiful. So the question is there a more functional way? Is there? What is it? Please clap for yourselves. Put your hands together. You're the best crowd ever. Yes, of course there is. ROP is the more functional way to handle errors. But how? So how do we implement ROP? Via something called Monads. How many people have heard of Monads? Amazing. So I don't need to talk about Monads. Let's just go. Wikipedia says a monad is a structure that combines program fragments, functions, and wraps their return values in a type with additional computation. Blah, 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 blah for the nerds. Let's break it down. Two things. Monads are able to carry out encapsulation and chaining. So let's start with encapsulation. It's like a box. So via this, you can say, this is the result of this function, put it in the box. It serves like a container. So was it a success? Put it in the box. Was it a failure? Put it in the box. So this box represents different states, right? But it serves like a container. Then imagine that every function that makes up the process actually returns a monad. What happens? That means we can change them all together. Monad in, monad out. Monad in, monad out. Exactly. And that's how we get encapsulation and chaining. Does it sound as nerdy as Wikipedia actually made it sound? Nah, it's pretty easy. But if none of the things I've said made any sense to you, that's okay and understandable. Let's write some code together. So if anything fails, it's you. Get ready. Yeah, I can see him preparing himself. So we're going to, thank God we just had lunch. We're going to build a monad to help us deliver lunch or maybe pizza to your doorstep. So I try to get something pretty easy and simple and fun for us to just explore ROP. How many people are ready? Okay, so let's do this. Too tiny? Too big, too small? Let me know. So I'm going to start increasing. Should I do some more? It's perfect. Okay, amazing. So this is what we have here. Every time I went through this code, I was sitting. Now it feels so weird to be doing it standing. Okay, so we have a launch class here. Pretty basic code. What's happening? Let's go through it. We have an order method which tries to send the order of the launch. So we have valid cities and we have available mails. So pretty basic. We have return invalid city unless the address is valid. So let's say I had to add Verona to the cities that are valid so you don't chase me away. We have London, Paris, Verona, and the meals that are available are pizza and pasta. I don't know why the P's, it was Copilot who picked all the P's, so please, this is not me. So we have pizza and pasta, and what we're doing here is return invalid city unless the address is valid. Return invalid meal unless the meal is available. I used invalid, 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 so it's pretty easy to just go through instead of writing a very long error message. But do we get everything that's happening here? It's pretty straightforward. And return invalid card unless the payment is successful. Does everybody get this piece of code? It's very easy. And then we have our spec. Let's go through the spec. So we are describing order, and when the city, meal, and card number are valid, we expect that the delivery is successful, right? But when the meal is not valid, we expect a failure. When the city is not valid, we expect a failure. When the card number is not valid, we expect a failure. Pretty simple and easy. So let's run the test. Let's see what happens. For example, 0 failures, everything works. So now let's start ROP. Let's see whether we'll be clapping in the next 5 minutes. So do you remember that we want types, right? We want to be able to wrap the results in a container. What shall we call it? I'm thinking outcome. I already used outcome. It's like, what was the outcome of this experiment you decided to whatever? So yes, results. Dry monad uses results, so I'm like, I'm going to go outcome-ish. Okay, so let's create a new file. I don't want to do that here, so let's do it here. Let's call it, oh, this is so weird to be bending to type. Is it in the right place? I don't think so. Okay, so let's call it outcome.rb. And what do we want, basically? So we're going to define the outcome module here, which is this. Nothing serious. We want types, right? Success and failure. So let's create our types. Let's create a success. And it will be the success class. I have some snippets that already come up, so just in case you see that, don't worry, soon we'll be doing everything together. So basically, how many of you are used to sorbet or sorbet? Okay. So I'm actually using, some people call it sorbet, some call it sorbet. I'll call it sorbet. So I'm using sorbet to type my files. It makes it easier to know where things are going wrong and we can move faster. It was created by Stripe. So let's say you have a function. The result is going to be a value. 2 plus 2, 4. That's the result, and it's a value. So let's wrap that here. Value. What will be the type? We don't practically know. Yes, because it could be anything, right? We also want an error type. So I'm just going to copy and paste. Let me call that failure so that we are failure.rb. Let's come here. So it's going to be a failure. What property do you think failure could have? When something fails, what do you expect it to have? Perfecto. You guys are so amazing. And what will be the type of the error message? Okay, let's talk about that later. Remind me. Should it be a string? Let's discuss that later. So basically now we have failure and success. But we know we could also have many other different types, right? So we have maybe. So it's not success, it's not failure, it's like a maybe. So basically we have outcome types. So let's put everything in an oh my God. Okay, let's rename that to outcome type.rb. And let's see, do I have something for outcome type? Yes, I have. Amazing. So in the outcome type, this is just going to encompass all the different types that we have. It could be success, it could be failure, it could be whatever you choose to call yours. Now let's come back to launch, which is why we are here. Basically, what we want to do is to say, if the valid cities include address, is it a failure or a success? Okay, so we want to be able to say something like outcome.success, and we give it a value. So let's say maybe address, or we say outcome.failure, and then we pass the error message, which is invalid city. This is why Sorbet is amazing. It's already telling us outcome doesn't know anything about a success or failure. So let's fix that. Let me see. Amazing. So now with outcome, we'll add success method and failure method. But what would this be? Remember, it would be thank you, Copilot, something like this. And for failure, it will be something like this. Let's not forget the new Ruby syntax that Lucy, is it Lucy or? Okay, so does this make sense? So we put everything in the box. If it's a success, good. If it's a failure, good. Now let's go back to launch and let's see what happens. Oh, yeah, it needs a value, right? So, and you guys didn't tell me. That's not nice. So this should be error message. Copilot is being nice to me. So let's see, is that fixed? Amazing, it's fixed, right? So let's replicate this for every single method so we can go fast. Who's bored already? Please don't be. Amazing. Okay, and this would be invalid meal. And let's send the card number here. And this would be invalid card. So let's run our tests now, right? And let's see what happens. Of course, everything fails. Does anybody know why? So when we check, is the meal valid? It tells us, burger successfully dispatched to London. But the meal is invalid. City, pizza successfully dispatched to Abuja. All of these things are invalid, but why does it pass? Let's see. Can anybody tell me in 2 seconds? Look at it and tell me why. We're all Ruby developers. Amazing. It's returning an object, so that means we need a way to be able to say if address is valid, is a success, right? Something like that. We need to be able to check if the method is successful because now it gives us a type. But as you can see, because this is not typed, Sobe doesn't know that that's not there. Did you see that? It just immediately appeared to tell me we don't have anything like that. So even though we say Ruby is flexible, typing is not so bad, no? They don't agree. They don't agree. It helps us go faster. Okay, so let's see. It tells us that we don't have any of these. So maybe we should do that. So let's see. On the outcome type, we need to be able to tell when something is a success or a failure. How do we know it's a success? Who can tell me? What? The object, okay, let me type the object so it's easy for us to identify. So the object is either, for now, it's either a success or a failure, right? Amazing. So how do you know if it's a success? Amazing. And how do you know it's a failure? So let's see now. Yeah, let's run our test again. Pam, pam, pam. Moment of truth. Let's run it from here. Yay, everything works. But have we achieved anything so far? Has anything practically changed in our code? We're still doing the same thing. Return unless this. If this, do this. But we have achieved encapsulation, right? We've been able to put in the results in a box. So the next thing would be what? Amazing. So that means we want to get rid of all of these things that do not help us. We don't like them. We want code that's easy to read. Why does this keep doing this? Okay. So we want to be able to chain all of this together. That means we're not going to be asking Is it a success or a failure? We want to automatically be able to say, if it's a success, just move on to the next. If it's a failure, do nothing. So we want to have something similar to this. So we bind them together. And same here, do meal, good, do card number, amazing. Let's have the end and end. Okay, so Sobert is already telling us that we do not have a dot bind, right? Okay, so, and this is an outcome type. So let's go to outcome type. Let's implement dot bind. Can anybody tell me what bind is going to look like? Ruby developers, let's go. Tell me. Tell me. Something like this? Something like this? Let's see if we can make it cleaner. So let's return self. That's amazing. Copilot is telling us already. If it's a failure, else, let's yield the value of the object. Does that make sense? Now, Sobert is going to complain because it doesn't know how to translate dot failure to this. If you're like me and you don't like seeing red, I'll just repeat myself instead of casting. Don't mind Sobert. It's not still as intelligent as it should be. So let's go back and let's see what's happening with launch. Everything is binding. So we no longer have errors, but let's run this. Ta-da! 3 things fail. Why? Can you see this? So the only thing that passes is the first test. Let's come to the first test. The only thing that passes is the first test, which says when the city, meal, and card are valid, everything works. The rest of them, we expected the errors. Invalid city, invalid meal, but what do we get? We're getting an outcome type with an error message. We actually get the monad. But we can see that the bind works because whenever the first is actually successful, it moves to the next. When that is successful, it moves to the next. So that means in our tests, we need to be able to say, where's my test file? This is it. I was looking right at it all the while. So we need to be able to say something like, expect the subject dot success or failure, something like that, since we already have that, right? To be true. Oops. Is that right? Let's run just this one and see what happens. Okay. Yes. So we're no longer checking for the error message because I'm going to try to go fast. I'm not going to implement error message now, but let's do this. So at all points when we expect a failure, we're just going to say, expect that failure is true. Does this make sense? Is everybody following? So let's run our test again. Yay! Everything passes. So do we get the whole idea of ROP? ROP is saying, put in a box, encapsulate, and chain. Now, is our code beautiful? Let's see. How does this look? Does it look a bit better? Más o menos. We no longer have return unless if and all the dances. But shouldn't we also return an outcome here? Shouldn't we also return a monad? If every function should return a monad. Even though this is the process, we should return a success per se, right? It was successful. Please someone tell me how many minutes I have more or left. MC is getting carried away with the code. Yes.
Let me check on the schedule.
One of our tests should fill now.
Yeah, you have another like 15 minutes.
Yay! Okay, so we expect that subject.success here should be true. So now let's run everything and let's see what happens. Ta-da! Everything works. Clap for yourselves. You did that. But, do you remember something I said we were going to get back to? Yes. How many people here believe that we should be returning strings here at every point? Invalid city, invalid mail, invalid card, invalid, invalid, invalid. Can we make it better in some way? Maybe. Let's see. What if we said that we should have a type, and this should be something like an error type? And let's create the error type, class error type. Copilot, help me, please. Yes. Yes, sorbet enum. How does sorbet? Yes, yes, yes. Copilot was going to help me there. And then it stopped. What happened? I would have gone faster. Amazing. So this is how sorbet enums look. Why is this? You see, this is the... Oh, so this class should come from the enum. Yes, amazing. So we are there. Sorbet is still telling me red. Pum, pum, pum. You see, these are the issues. This is why you shouldn't do live coding. Now, I do not remember the syntax for enum in sorbet. Yeah, and I was expecting that Copilot should help me. Perfect. You see, it was the S. Okay, so we have invalid city, invalid mail, invalid card. What if we just call all of these invalid param? Or maybe, in our case, would not supported do a good job? So imagine that in your code base you had unauthorized, forbidden, not found, all of these usual errors that you encounter so many times. Does it make sense at every point to say outcome.failure, not found? Then you go to the other place, outcome.failure, not found, for something that practically keeps repeating itself. So we can have stuff like invalid, we can have something like forbidden, stuff like this, right? And within our outcome now, we can also have a forbidden method, maybe, so that here, where we have, remember that in our failure, this is not nillable. So what if we made our error message nillable? Because maybe we could have a default based on whatever it was that we chose. So error message here is nil, and error message here is nil. But we need a type. So let's give it a type of error type, not supported, something like that. So do all our tests still pass? Yes, all our tests still pass. But let's come to launch. And now, let's say you were trying to access a card that it's not yours, and the external service told us, oh, this person, blah, 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 is a scammer, something, something, something happened. So we can just say outcome.forbidden. Does that work? That's all. Here, maybe we don't want to say invalid mail. We just want to say invalid param or something. So let's add an invalid param method here. Yes, same. And let's come back here. How many minutes do I have left? Amazing. So maybe we don't even have an error message because now we have something default somewhere that we are going to indicate. And now in our tests, we can even be more explicit, and our tests are even more readable. So we can have something like this. Now that we know it's a failure, expect the subject dot error type dot to equal, let's say, error type forbidden. Yes. Let's see what happens. That shouldn't work because we should get outcome. Yes. Let's run this again. Yeah, still fails because we don't have error type for an outcome. So let's add that and we are done. What will the error type be? It would be the object.type, right? But that's only if it's a failure, because if it's a success, then there's no error type. So let's not forget that. Let's return nil unless it's a failure, and then let's do object.type. So let's go again. Ta-da! Everything works. So in 20 minutes, we've been able to go from all of what we had before to this. Now, this is not the end. This is just an introduction to help us see how Monads work, ROP works, in the fact that it helps us encapsulate and chain. And imagine that you already have this abstraction. You could use it everywhere in your code base where all your functions return outcomes and you can easily chain them wherever. You can chain several processes together and you don't need to bother about where it failed because you will know exactly where it failed. You don't need to say, if it fails here, then return this. If this happens here, return this. So now let us look at two other things. That felt like magic. Single track functions and the end user. Those are two things that I haven't talked about and we should talk about. What are single track functions? A single track function generally does not generate any errors. So everything that we have looked at actually tells us failure or success. But what if I just wanted to do something with the code? So like available meals or add promo. So you want to buy pizza, add promo, add 1 chicken. That's not going to be a success or a failure, right? It's just going to do something. So there's no, if this happens, then do this. So how do we deal with this? In this case, as I said, maybe you validate the user. It's a failure or a success. You get to add promo, it's just a success. And then you have to move to failure or success. How do we bind all of this together since this doesn't return an outcome because it's not something that fails? We can do this via a .map. Can you see that? We can create a map function for our outcome. And if it's a failure, we just return an outcome type so that you can continue to bind it with other functions. Else, we yield the value, and at the end, we send a success. As you can see, I tried to map with pizza and add a piece of chicken, and you can see what we have here. We still get the outcome type, the value of pizza and 1 chicken. But when it fails, nothing happens, just fails. In the code we just looked at, this looks something like this. Address is valid, you bind. Meal is available, you map, and you add a promo to that meal. And then you continue your binding. Does this make sense? So that's for single track functions. So see single track functions as a combination of bind and success, which is a map. Now, the end user does not understand outcome types. So imagine now, all of this we're saying is our code base, right? This is how we write code. We have chosen to handle errors this way. You're the end user. You just want to call an endpoint and get JSON, right? Imagine I send you outcome type, success value, error type. You're like, huh? What's happening here? So how do we deal with the end user? You can unwrap the box. Remember that I said monads are like containers or boxes that contain results. So let's unwrap the box for the user. First step process. We can have an unwrap error, and it's going to be a standard error. So this way, we just initialize it with a failure, right? Because the only way we get here is if there's a failure. And then this is what we can have, an unwrap method that returns to the user the value if it's a success, but if it's not, it will raise the unwrap error. So your controller could look something like this. Order launch.new params, and you order. Your result, you unwrap it, and you send JSON to the user. But what happens if this fails? Who can tell me? From this code here, what happens if when you call your unwrap, it was actually a failure? What happens? What? Yes, but so that means the user wouldn't get anything, right? But we need to find a way to tell the user this, that there was an error. So we can do this, rescue from unwrap error in your application controller, and now you can do whatever you want. Your messages, status code by type. So if it's forbidden, send 403. If it's not found, send 404. You can have all of these stated, and imagine that you just had these 4 things and everything we have done here. Everything is set for the entire or the entirety of your code base. All you need to do is unwrap in your controller, and it's pretty easy to understand. You can name it whatever you want, not necessarily unwrap, but you get the picture. So what do we get at the end of the day from all of these things? Whoa, I made it. We have composable and more readable code. Even our tests are more readable. You can just say, was this a failure? Yes. What type of error did I expect? I expected forbidden, I got forbidden. That's all, you move on. So imagine that I were new to your code base. It would be easy for me to just read your code and understand exactly what's happening here. Oh, they validate the user and then they get the payment. But if the user's name is Peter, we add promo, blah, blah, blah. It's just easy to read. And the test, you can just say, oh, forbidden here. We don't need to start looking at each and every single error message. Efficient error handling, consistency. Every method returns an outcome and you can chain it for as long as you like. And you don't have to be bothered because you know once it's an error, it returns an error. And you don't need to bother about that. Explicit control flow and reduced boilerplate. Some people would not agree because of the binds. But we have dry monads that have implemented a do notation. And you can use yield. I personally don't like it. I should have created like code snippets for that. You have, in our case, you would have yield validate user. Yield blah, blah, blah. Yield. I find it ew. But that's just me. I feel it's readable when you say this dot bind. I think I can read it and even a baby can see it and say, okay, so this binds to this and binds to this, but it might just be me as he's, old people don't like to change. Maybe that's the case here. But at the end of the day, what do we have? A happy code base, a happy user, happy Ruby developers, happy everything. Can you think of anything that could go wrong? Except live coding, of course. But any questions? Yeah, that's it. So yeah, that's the link. That's a QR code to the link to the GitHub repo. I pushed all of this. So you have the main branch, which has what we started with, and you have the use outcome branch, which has everything. It even has unwrap and map and every other thing I talked about that we couldn't code. Yeah, and you can find me in any of these places. Questions? 5 minutes. I didn't know I would make it.
Been great. One question over there.
Please.
Can I have the microphone? Thanks. Thank you. Bring it over there. There you go.
What's the advantage of monads and I don't have the word. Like, why shouldn't we just throw an exception, erase an exception when something fails and it goes basically automatically in the failure track, which stops the execution, and at the end of the process we can just do rescue, and the type of the exception is like the failure type, and we avoid all the boxing and unboxing. And
okay, so we are actually raising an error via the unwrap error. If you remember, we're actually raising it, but we're not raising it within the code. We're raising it in one place, which is in the outcome. With what you've said, at every point where something fails, you raise an error. Yeah. At every point where something fails, you raise an error. With a monad, you don't need to do that. You just leave everything in the box, and at the end of the day, if it fails at any point, we are raising the error once in the outcome. So it's practically almost the same thing, but we do it in one place. Yeah, but like raising errors is not a bad thing. Like it says this thing failed for this reason, and it also gives like a stack trace. For example, with monads, we say, okay, this is a failure, it's an unauthorized error, but if we have 3 functions that can fail for that reason, like we don't know which one failed. You know exactly where it failed with a monad. You can tell exactly where it failed because we have the dot bind. So let's say in our case, we have validate user dot bind, this dot bind. If it fails in the first point, that's where the error is raised from because it doesn't bind to the next. So it doesn't continue the process. So we know exactly where it fails. And you can't have three points of errors failing. You would have just it fail at one point because remember that the success of a process is the success of the individual function. So once one fails, that's where it stops and that's where it fails and that's the error that we receive. Yeah. So you know exactly where it fails. You can't have 3 of them. Somebody else wants to say something?
So sorry. An alternate response is that when you start working with errors, right, you maybe want to name them. So you start putting names for the errors to know where they are. So if you have a huge code base, then you have a wide array of names for errors, right? It seems simple in this simple example, but let's say you have, I don't know, 200 modules. So each one has errors, and then the error has to have a name. And you can, it works, but then it creates a wide space for exceptions. They might have message, you might add some other interface like, I don't know, a code or things to it, right? So it's not standardized. Or you can go the other way to say, I will raise one single error and I will put a payload of code. And that is similar to going to this direction, organizing errors in some way. So I think Monads is more like, you know that wherever you are, the failure looks like this and it has a payload. And you can raise an exception with it if you want, but it's a common interface in a way. This is how I see it. I don't know.
Yeah, also, if it's very important for you to raise an exception, let's say there are points where you really need to raise an exception here, you can. Remember that we have a failure type and we have error message, we have type. You can also have exception there as a key and add the exception. And in your raise on wrap, let me see here where we rescue. Here, if there's an exception, you can raise that exception there. Does that make sense? In some way, más o menos. Also, what you have said is practically almost the same thing like what we do in Monads. It's just that we do it in one place. So let's say you raise at one point, we are already raising the error in one place, and we will still raise. It's not like we would be silent to errors, no. But everything is now composable. Do you understand? Because let's say it was successful, you cannot compose it to the next method. But if we wrap everything in a monad, we can actually compose methods, irrespective of whether they are successful or a failure. Any more questions?